This is something that expands over many thousands of kilometers or miles, if you like. And you can see these great big bands, which I'll define in just a moment. And all the air sweeping into here is going over very, very warm water. And as it goes over that warm water, it picks up moisture. And we'll see in a minute why that's important. So a couple of definitions. This is the eye of the hurricane. And this is the eye wall down through here. This is where the most vigorous and strongest winds take place. You'll see a picture in just a moment of that. And these are the spiral rain bands. You get big spirals coming in. I think you all have seen those. You get the wind fields, and if you're ever in a sailboat and somebody says a hurricane is coming, don't be in the northeast sector, because that's where the winds are much stronger. As we'll see later on, this hurricane is moving up the coast here. See all the winds here on towards the shore, moving towards the shore. That'll turn out to be very, very important, especially if you live on the coast of Georgia. This is what a cross-section of a hurricane looks like. And it's 1,000 kilometers, that's about 500 or 600 miles. And this is about 6 or 7 miles in the vertical, very, very deep. And the air spirals in below and into these spiral bands. The air, it rises up through here, and as it rises, it cools and water condenses, and that gives off heat. And that's the fuel, if you like. And the warmer the sea surface temperature, the more fuel there is for a hurricane. And as we'll see, that means hurricanes will probably get stronger if the sea surface temperature keeps rising with global warming. This is another cross-section, a little nicer one, showing the wind spiraling in towards this hurricane, and is up, descending air here, and the eye where the air actually goes down a little bit, and then it spirals away, and the winds here can be up to 100, 150 miles an hour. So some hurricane facts for you. Tropical storms need very warm water, at least 80 degrees Fahrenheit, to form. The warm water evaporates in the storm, and the warm water evaporates around the storm, I should say, and as it rises up, it gives you energy, and the thing gets faster and faster. It's almost balanced actually by friction. The average hurricane has as much energy in a day as the entire US uses in 6 months. Now think about that for a moment, because a lot of people say, well, why do we put great paddle wheels that go the opposite direction to slow a hurricane down? But if a hurricane uses as much energy as all the United States in 6 months in just one day, that would have to be a very, very powerful paddle to be able to do that. So things to stop hurricanes, using nuclear weapons or whatever, are not going to really work very much. You'd have to have many, many nuclear weapons to stop a storm. Probably the pollution caused by the nuclear weapons will be far worse than these. So, hurricanes also exist in different parts of the world. Here we are in the North Atlantic Ocean. Here is Georgia. About 11% of the hurricanes every year form in this region, and here in the East Pacific, another 17%. Where most form in the world is in the Northwest Pacific, and then in the Indian Ocean and around Australia. So they're spread everywhere. They're called different things. What we call hurricanes are typhoons here and tropical cyclones. Exactly the same, but different names. This is one of my favorite pictures. It's 2 super typhoons. That's the strongest they get. There's 150 miles per hour spiraling around. This is the Philippines here, and this is Japan. 2 storms so close together in proximity. That happens quite a lot in the Northwest Pacific. Yes?
Could they have moved together and caused an even bigger one?
No, what they tend to do, they tend to spiral around each other. It's a special effect. But 2 vortices tend not to join, but to move around each other. This is what we found in the United States. These are all the storms from 1970 to 2003. And you see that generally, most of them form over here and move up. Some of them form in the Gulf of Mexico, and some move into the Gulf of Mexico. And they're the ones we're particularly concerned with, the ones that hit the coast of the United States and the ones that form in this region through here. The ones that form here and move up northward, we're not particularly concerned about. These are all the storms that have hit the United States in the last 54 years, and you can see Everywhere there's a color, this refers to how strong the storm was. If it was a red, that means it's a category 5. And if it's a yellow, it's category 1. You can see almost everywhere along the coast, except here and Georgia, doesn't have particularly many impacts. There's hardly a place that isn't affected by hurricanes. There are a lot of things that are necessary for a hurricane to form. The sea surface temperature has to be warm. The winds can't vary too much in the vertical. There's got to be a lot of moisture around. It has to be unstable. And a number of factors all have to come together to form a hurricane. This is what the formation, if we were to draw the contour for 80 degrees Fahrenheit or 26.5, it's this line here. And you see here in the northern hemisphere that almost all storms form within that warm water. Whereas for the major hurricanes, those which are category 3, 4, and 5, they all form in temperatures warmer than about 82 or 83 degrees Fahrenheit. So the warmer the temperature, generally the stronger the hurricane will be.
I think there's a question, Peter, question.
Oh, I'm sorry, yes. Yeah, well, stability is we can perhaps talk about it more in detail, you and I together later, but what it means is that as you bring all this water vapor in a gas towards the center, and if you raise it up, it tends to release heat, which brings in more moisture because you lower the pressure. The pressure gets very, very low. And so you have this sort of instability where it gets faster and faster and faster until at some stage the friction on the surface of the ocean balances the inflow, and you get a sort of a state where a hurricane lasting a long, long time, not getting stronger anymore. Probably didn't explain that very well, but let's chat a bit later on that.
One more question.
Yes.
My question is, do hurricanes contribute to global warming?
That's a very, very good question. And the answer is probably no, they respond. We've always had hurricanes. And hurricanes do a very, very important thing. Let me show you. Go back one diagram. And one thing you notice about these hurricanes is they all start off in the tropics. And they all finish up at higher latitudes. And what do we know about the tropics? This is very, very warm here. This is much colder. So a hurricane takes a lot of heat and sends it all the way to the north. So it warms the polar regions and it cools the tropics. Just one sec. And what that means is that if the tropics get warmer and warmer, the storms will have to carry more and more energy to make a balance between the polar regions and the tropics. Yes?
So a hurricane can't form in polar waters yet?
Right. There are some storms called polar storms, which are very similar to hurricanes, very small, intense, midget hurricanes. And they're formed by different processes.